Good evening. All right, everybody take your seats. I am so delighted to be able to welcome you to the 186th meeting of the AAAS, the American Association for the Advancement of Science. I'm Peggy Hamburg, Chair of the AAAS Board of Directors and Foreign Secretary of the National Academy of Medicine. And it's really a pleasure to see you all in this beautiful city. Raining, yes, but beautiful and a wonderful host for this terrific meeting. This meeting is really a great opportunity for us to come together as a community dedicated to science and to all the myriad ways in which science matters. An opportunity to learn, to share ideas, discuss challenges before us, and how best to make a difference, and hopefully to have some fun. I'd like to acknowledge that we're on indigenous land, the traditional territories of the Coast Salish people, which touch the shared waters of all the tribes and bands within the Suquamish, Tulalip, and Muckleshoot nations. We're deeply appreciative for the tribes and Native people who founded and remain important parts of this community. Before we begin tonight's program, we'd also like to recognize the members of the American Junior Academy of Sciences, or AAAS. And this is the only national honor society recognizing America's high school students for outstanding scientific research. The winners of statewide competitions are nominated to represent their states at the National AAAS Convention, which is held in conjunction with our annual meeting. Competition winners will present their posters tomorrow in the Expo Hall, and I hope that you'll all take the time to meet and encourage these young scholars. And at this time, I'd like to ask the AAAS students to stand and be recognized. Thank you very much. Glad to see how many of you there are. AAAS is committed to providing a safe and productive meeting environment that fosters open dialogue and the exchange of scientific ideas, promotes equal opportunities and treatment for all participants, and is free of harassment and discrimination. Simply put, harassment of any kind has no place at this or any scientific gathering, and we will not tolerate it. By registering at this meeting, you agree to abide by the AAAS Meeting Code of Conduct. It's available at meetings at AAAS.org/policies on the meeting mobile app, and it's also in the printed pocket guide if you want to take a look. Over the course of the next 3 days, if you or someone you know feels that they've been the target of inappropriate or harassing behavior, AAAS offers a quiet and discreet safe space where you can confidentially and free of charge utilize the services of a trained professional who will offer information, emotional support, and assistance in finding resources and deciding next steps. You do not need to file a formal report to use these services, and they're open to anyone for any reason. The safe space is located in room 310 on the 3rd level of the convention center, and will be available between 8 a.m. and 5 p.m. each day. Let's join together as a community and commit to no one being made to feel out of place, unwelcome, or harassed at this meeting for who they are, where they come from, or what they believe. It's also critically important for us to recognize that the AAAS annual meeting is a place where people of all backgrounds are welcome and their perspectives are valued. Science depends on openness, transparency, and the free flow of ideas and people. AAAS has spoken out against limitations on the ability of scientists to communicate with their peers and with the public, particularly through participation at meetings such as this one. Simply put, continued restriction on this type of collaboration will harm the scientific enterprise. AAAS is launching a new initiative, Science Beyond Borders, supported by the generous support of Jan and Marika Vilcek and the Vilcek Foundation, which will engage the STEM community directly to highlight the contributions of foreign-born scientists to the scientific enterprise in the US, seeking to understand and make visible the challenges faced by immigrant scientists in the US and understand whether, how, and why international collaborations are shifting in the face of current political and public policy shifts. We want to hear directly from you, so please visit the website on the screen for more information. Is it on the screen? Okay. We want you to be able to visit the website so that you can get more information on how you can participate in this important new endeavor. As we gather here, some of our international colleagues have been unable to join us because of restrictive government policies, while others have been affected by a tragic course of events. There was a sizable delegation from China that had registered to attend and participate in the annual meeting. As the events in China related to the novel coronavirus have unfolded in recent weeks, AAAS worked with our counterparts at the Chinese Embassy and counterpart organizations in China to determine the status of the participants and if they were located in areas directly affected by travel restrictions to arrange for their remote participation in our meeting to the greatest extent possible. We value the diversity of our participants in our programs and are committed to doing all we can to preserve the important perspectives that are offered through international participation and collaboration. Our thoughts and concern remain with our friends, colleagues, and collaborators in China and around the world, and we express our gratitude to the researchers, clinicians, and public health officials who are on the front lines of this epidemic. It's wonderful that we are all here together, though, and to see so many new and familiar faces in the audience tonight. Many of us traveled a great distance to be here. In that regard, AAAS recognizes the environmental impact of our and other scientific gatherings, and we're committed to mitigating the impact. Being together over the next several days is a unique and unparalleled opportunity that as of yet cannot be recreated virtually. We hope that each of you, though, makes the most of your time here to reconnect with existing friends and colleagues, connect with new ones, and discover the promise of interdisciplinary collaboration for advancing the scientific endeavor. The AAAS annual meeting aims to be a zero-waste event, leaving no landfill trace of our activities, and whenever possible, leaving the community in better condition than we found it. We're making concerted efforts this year by collecting data and setting baselines against we'll assess our progress in the future. To do this all, participants from AAAS really need to help us in this collective effort to green this meeting. We're working cooperatively with all of our meeting venues, including here in the Convention Center and the meeting hotels, to track energy use and waste disposal. After the conference, you'll receive a survey to report on your meeting experience. As part of this survey, we'll ask you questions about your own eco efforts. So please help us collect as much data as possible. Reducing our collective footprint will require everyone's active participation. And suggestions to reduce your own footprint while here in Seattle are available in the meeting mobile app. So a lot to think about as we start our meeting. And it's now my honor to be able to present two of AAAS's most prestigious awards. Each year, AAAS recognizes significant contributions to science and the public's understanding of science. First, the Philip Hague Abelson Prize. Its namesake was the editor-in-chief of Science from 1962 to 1984. A 1987 recipient of the National Medal of Science Abelson had a long and distinguished career as a physical chemist at the Carnegie Institution in Washington, including 7 years as its president. The Abelson Prize was established by the AAAS Board of Directors in 1985 and is awarded annually either to a public servant in recognition of sustained exceptional contributions to advancing science, or to a scientist whose career has been distinguished both for scientific achievement and for other notable services to the scientific community. Let's find out more about the incredible career of this year's recipient.
The Philip Hague Abelson Prize honors an individual for groundbreaking contributions to science in America, either as a public servant or a scientist or engineer with a distinguished record of scientific achievement and other notable services to the community. This year, we honor Chad A. Merkin of Northwestern University for his extraordinary contributions to chemistry and nanoscience, national service and science policy leadership, and support of diversity in science. Merkin is the director of Northwestern's International Institute for Nanotechnology and the George B. Rathman Professor of Chemistry, Medicine, Material Science and Engineering, Biomedical Engineering, and Chemical and Biological Engineering. He is one of the most cited chemists in the world and recognized as a nanoscience pioneer. Merkin invented and developed a series of scanning probe-based nanolithography techniques, marking a fundamental change in the way researchers think about synthesizing miniaturized chemical and biological systems and engage in high-throughput material synthesis and discovery. He is also known for his invention and development of spherical nucleic acids, nanostructures that form the basis of a new type of chemistry where particle atoms and DNA bonds can be used to engineer colloidal crystals. In addition, Merkin uses spherical nucleic acids in high-sensitivity biodetection schemes, potent gene regulation, and advanced immunotherapies as well. Merkin is also known for his invention and development of on-wire lithography and coaxial lithography, and contributions to supramolecular chemistry and nanoparticle synthesis. This prolific scientist has published more than 750 papers and over 1,200 patent applications. Of these applications, over 350 have been issued. The inventions and processes coming out of his laboratory have resulted in his founding of multiple companies that have commercialized over 2,000 products worldwide. Merkin is also one of a precious few elected to all 3 branches of the U.S. National Academies: Sciences, Engineering, and Medicine. On the national policy front, Merkin has advised multiple U.S. presidents, the American Chemical Society, the Gordon Research Conferences, and the National Academy of Sciences. As a champion of diversity, he has trained over 270 students and postdoctoral associates. Of these, over 110 are now faculty leaders at the world's top universities. Over a third of his mentees have come from underrepresented groups. Merkin's a distinguished chemist who's made profound contributions through his groundbreaking research, science policy leadership, and support of diversity. Chad A. Merkin, recipient of the 2020 Philip Hague Abelson Prize.
So it is now my great pleasure to be able to present the 2020 Philip Hague Abelson Prize to Chad A. Merkin, Director of the International Institute for Nanotechnology and the George B. Rathman Professor of Chemistry, Professor of Chemical and Biological Engineering, Professor of Biomedical Engineering, Professor of Materials Science and Engineering, and Professor of Medicine at Northwestern University. I said I thought he had more titles than anyone I know, and he said a lot of faculty meetings. Next, the Newcomb Cleveland Prize. AAAS's oldest award, the Newcomb Cleveland Prize, was established in 1923 with funds donated, then anonymously, by Newcomb Cleveland, and was originally called the AAAS $1,000 prize until Mr. Cleveland's death in 1951. The prize is awarded to the author or authors of an outstanding research article or report published in Science. Today, the award bestows a cash prize of $25,000. The prize has been generously supported over many years by the Fodor Family Trust. Steven Fodor, who recently received the prize, back in 1992, I guess, established an endowment in 2019 to sustain it in perpetuity. So thank you, Steven, for that generous gift. And let's find out now about this year's winning paper and its outstanding researcher authors.
The AAAS Newcomb Cleveland Prize, our oldest award, recognizes an outstanding paper published in the research articles or report sections in the journal Science each year. The winning paper is chosen based on the quality of the scholarship, innovation, presentation, likelihood of influencing the field, and wider interdisciplinary significance. This year, we present the prize to the research paper entitled Transgenic Metarhizium Rapidly Kills Mosquitoes in a Malaria Endemic Region of Burkina Faso, published in Science on May 31, 2019. The paper was an NIH-funded international collaboration between researchers at the University of Maryland Department of Entomology and IRSS Center Miraz in Burkina Faso. The team's goal was to develop a fungal biotechnology to combat mosquitoes that carry malaria. Malaria is a huge threat in the West African nation, with over 10 million confirmed cases annually in a population of about 20 million. Decades of insecticide use has led many mosquito populations that carry malaria parasites to become resistant to it. In response, scientists have intensified efforts to genetically modify mosquitoes and other organisms that can help effectively control them and eradicate malaria. The study showed that a naturally occurring fungus engineered to deliver an insect-specific toxin to mosquitoes safely eliminated 99% of them in a screen-enclosed, simulated village setting in Burkina Faso. The fungus, called Metarhizium pingxiense, is a naturally occurring pathogen that infects insects in the wild and kills them slowly. In the mosquito's case, a fungal spore lands on the outside of the insect, then penetrates the interior until it reaches its blood, called hemolymph. Within the hemolymph, the spore grows a protein shell that makes it invisible to the insect's immune system and multiplies as a budding yeast-like fungus. But it still does not kill mosquitoes fast enough to control them effectively. To address this, researchers engineered Metarhizium to produce a toxin called hybrid, derived from an Australian spider's venom, which kills mosquitoes more rapidly than they can breed. Using transgenic techniques, the researchers make the fungus produce the hybrid toxin only once it has reached the hemolymph and donned its invisibility cloak. They trialed its effectiveness for controlling mosquitoes in near-field conditions in Burkina Faso in a setup called Mosquitosphere. Inside this 6,550 square foot structure, multiple screened chambers contained experimental huts, plants, small mosquito breeding pools, and calves that served as their food source. During the study, mosquitoes exposed to transgenic fungi died much more quickly and in larger numbers than those exposed to wild fungi, and the population collapsed within 45 days. The judges were particularly impressed with the team's ability to successfully establish the right environmental conditions, including vegetation, breeding sites, and blood sources needed to sustain a mosquito population. Testing the engineered Metarhizium under the controlled yet realistic conditions of Mosquitosphere is a key step before launching critical epidemiological field studies. Transgenic Metarhizium rapidly kills mosquitoes in a malaria endemic region of Burkina Faso, recipient of this year's AAAS Newcomb Cleveland Prize.
So it's now my pleasure to present the 2019 AAAS Newcomb Cleveland Prize for Transgenic Metarhizium Rapidly Kills Mosquitoes in a Malaria Endemic Region of Burkina Faso. And representing this paper's authors are Brian Lovett of the University of Maryland, College Park, Etienne Bilgo of Institut de Recherche en Sciences de la Santé, Centre Miraz, Abdoulaye Dubayate of Institut de Recherche en Sciences de la Santé, Centre Miraz, and Raymond Saint-Léger of the University of Maryland, College Park. Well, they wrote a great paper, but they didn't stand in the right order for their prizes. So congratulations to tonight's winners. And please join us each evening for additional award presentations. The development of the exceptional multidisciplinary program you'll enjoy over the next 3 days has been guided by AAAS President Steven Chu, who will deliver his presidential address very shortly, along with the truly dedicated and amazing annual meeting program committee that works to put this meeting together year-round. Thanks to Steve and the committee for their excellent work this year, and we really, truly do have an exciting program. We're also honored to have in attendance tonight our honorary local co-chair. I'm not going to get this right, and she taught me how to say it. Anna-Mari Kause, president of the University of Washington, which is really so generous in hosting us for this meeting and being our host university. I'm pleased that I'll be able to invite President Kause to the podium. Let me first tell you just a little bit about her background. In 2015, she became the 33rd president of the University of Washington, one of America's premier public universities, where she's also professor of psychology and American ethnic studies, with secondary appointments in gender, women, and sexuality studies, and in the College of Education. Prior to being named UW's president, she served for 4 years as its provost and executive vice president, overseeing the education, research, and service missions of the university's schools, colleges, and other academic units. A member of the UW faculty since 1986, President Kause has also previously served as chair of American Ethnic Studies, chair of psychology, and executive vice provost, and dean of the College of Arts and Sciences. She was raised in Miami after emigrating with her family from Cuba, and President Kause completed her undergraduate studies in English and psychology at the University of Miami. She holds a PhD in psychology with a concentration in child clinical and community psychology from Yale. She maintains an active research program focusing on adolescent development with a special emphasis on at-risk youth. She's a strong advocate for women and underrepresented minorities in STEM fields, and she remains active in the classroom and continues to teach and mentor undergraduate and graduate students. For her teaching, scholarship, and advocacy, Professor Kause has received numerous awards, including the Dalmas Taylor Distinguished Contribution Award, the Luis Fernando Esteban Public Service Award, the James M. Jones Lifetime Achievement Award of the American Psychological Association, the Grace Hopper Exemplary Leadership Award, and the Distinguished Contribution Award from the Society for Community Research and Action. In 1999, she was awarded the Distinguished Teaching Award, the highest honor of the University of Washington, she was recognized, of course, for the work with students in and outside the classroom. So please join me in recognizing and welcoming President Kause.
Gosh, what a lovely crowd. You look absolutely fabulous. Thank you so much, Peggy, and hello to so many colleagues and friends, some of which I know and some of which I look forward to getting to know. On behalf of the University of Washington and the City of Seattle, I'm honored to welcome you, and I particularly want to thank the board and the staff of AAAS for bringing everybody here to my city that has actually been my home for over 30 years. It's great to have you all here. The AAAS annual meeting is really unlike any other in its diversity of scholarship, fields of expertise, and the professions and perspectives of the people who take part. But for all of our differences, we're united by one very important thing: curiosity. Curiosity is intrinsic to humanity. The desire to understand our world and ourselves and to learn new things is a trait that offered humans' earliest ancestors an evolutionary leg up. I just spent, actually, the last week in the Galapagos and was thinking a lot about evolution, about what it is that makes humans so distinct. And that curiosity, the drive to know, is absolutely central to it. Curiosity is essential to our continued survival, an endlessly renewable fuel that feeds exploration, discovery, and innovation. We share the conviction that by combining curiosity with rigor and teamwork, it allows our species to move forward, at times by inches, and at times by leaps and bounds. Now, I don't want to feed into some of the stereotypes that you might have of the Pacific Northwest and sound too woo-woo, so to speak, but it is my absolute and firm belief that the human imagination, unfettered, will take us to important places, even if we don't know what those places are when we're starting our work. The power of basic research is absolutely critical. But at the end of the day, we also want to apply that knowledge to serving the greater good. And that desire to wed that basic research, that curiosity, that imagination to a meaningful purpose is not just something that infuses the University of Washington, but that really you will see across the people and organizations in this very special part of the world, the Pacific Northwest. We're thrilled to be able to welcome you to this hub of research and innovation, and I hope that you find yourself making new connections that you never expected before you came here. This region has an unparalleled constellation of nonprofits, NGOs, and businesses invested in a healthier future for our people and our planet. This concentration, both on our UW campus and off, was the catalyst for the launch of our population health initiative 4 years ago. I think all our universities draw on our regions, on those things that are special around us as we put together initiatives, as we make our mark on the world. And for us, in this particular part of the world, population health is really what made the most sense. The Population Health Initiative was created to leverage the incredible nexus of talent and resources to help all people live longer and healthier lives. And at UW, this is very central to our work, but we also want to be a convener of others that are involved in doing this work. The UW is home to outstanding health sciences. We have schools of medicine, nursing, pharmacy, dentistry, public health, and social work. But improving population health also takes experts in law, in information sciences, in public policy, in arts, computer sciences, engineering, communication, journalism, and even a few psychologists. It really is, the important thing is that health is a lot more than just about the absence of disease, although, of course, that's central. Healthy, thriving people need clean, safe living spaces, economic and social justice, and no single organization can create that future, but together we can. I hope that some of you come and visit our campus. I know that some of you will. And you'll notice a brand new building coming up. Later this year, we will be opening the Hans Rosling Center for Population Health. And it has special places for visiting scientists, because we want it to be a real convener of people across disciplines and across universities. It'll serve as a new hub near the center of campus for collaborations across the university, state, nation, and world, and we hope that some of you will end up spending some time here in this visit, but more so later. Because I really hope that we can work together to improve health and well-being of people across the globe. I can't think of a more urgent problem. The challenges we face are daunting and global in scale. Climate change, pandemics, technology that threaten to undermine our democratic values. But history shows that we're equal to the challenge. Vaccines, clean energy technology, huge advances in computer power have already changed the world. And the next great leap forward for humanity could well be in this room. I love the fact that we have so many senior and junior and budding sciences all together. It's this intergenerational and interdisciplinary mix that I think will lead to that next innovation and that next leap forward for humanity. Research advances, new cures and treatments, informed policy, technology that will help us connect here on Earth or throughout the cosmos. Whatever unique story led each of us to our professions, to this room, to this moment today, we share the conviction that research and innovation can better humanity. When we envision tomorrow's Earth, we have the privilege of optimism. We know firsthand that scientific discovery can not only show us the future, but can change it for the better. The power and responsibility for making that change lies in our hands, begins today, right here. I look forward to the next 3 days and seeing what we can take from here to change the world, to change our lives. Thank you so much for inviting me to say a few words and for inviting us to be your host. Thank you.
Well, I think that those words are inspiring. What a wonderful way to get us started for this annual meeting, and we all can use an infusion of optimism. And as the good teacher that you are, you taught me a new word, whoa. So now I'd like to thank our sponsors. We've just heard from one of our important and generous sponsors, our host university of Washington. But I also want to recognize and thank them for their support of this annual meeting, the European Commission, the UK Research and Innovation, Johnson & Johnson Innovation, and Microsoft. So thank you all very much. And tonight's program in particular is made possible by generous support from Johnson & Johnson Innovation, a longtime partner of AAAS. The global healthcare company shares AAAS's commitment to demonstrating that science is everywhere, that it impacts our lives in every imaginable way. Johnson & Johnson is working on many fronts to do this, including through its multifaceted Champions of Science initiative to convene and catalyze champions of science and engage people of all generations and backgrounds to see the unlimited opportunities that science can bring. We're looking forward to hearing from Seema Kumar, Johnson & Johnson's Vice President of Innovation, Global Health, and Policy Communications. She had originally planned to be with us this evening, but unfortunately for us, Seema's been called back to New Jersey to help manage Johnson & Johnson's ongoing response to the novel coronavirus outbreak. She's responsible for maintaining the company's leadership position in innovation and global health and is herself a tremendous champion of science. She can be seen around the world talking about the importance of science and technology in creating healthier and better futures for us all. Seema and her colleagues at J&J believe that today, more than ever, science needs champions who engage society in a broad way, and we're grateful that they've recognized AAAS as an important collaborator in this work and for the company's ongoing and expanding partnership and support. So let's take a few minutes to hear from Seema, who's joining us on the big screen.
Hello, everyone. I'm sorry I couldn't join you in person at AAAS due to some urgent priorities related to Johnson & Johnson's work on the coronavirus response. But thank you for letting me share a few thoughts via video. I'm very pleased to be able to address a room full of champions of science. Multiple surveys have shown that over the past 2 decades, trust in facts has eroded among the general public. This truth decay, which blurs the lines between opinion and fact, manifests as declining trust in respected sources of fact and impacts how people view science. But as all of you know, science touches our lives in so many different ways. From the phone each of us has in our pocket to the medicines we have in our bathroom cabinets. In the last few weeks, science has once again come to the forefront as the world scrambles to deal with the emergence of a new pandemic threat, the coronavirus. People turn to science in times of anxiety and uncertainty because it brings hope. It helps us understand our world, and it is a source of tangible solutions. At Johnson & Johnson, we've mobilized a multi-pronged response to the coronavirus outbreak by working together with multiple partners to get to a vaccine within the shortest possible time. Days after getting the coronavirus sequence, scientists at Johnson & Johnson started biological work to make a vaccine, and I'm happy to tell you that we're making rapid progress. We hope to start animal experiments in the next several weeks, and in parallel, we're working on evaluating upscaling of the vaccine in order to start clinical trials as soon as possible later this year. Using the same technology created for the development and manufacture of Johnson & Johnson's Ebola vaccine, and to construct the Zika, RSV, and HIV vaccine candidates, we aim to make several million doses of a vaccine for the coronavirus before year-end. We're also working with global partners to screen our antiviral libraries to accelerate discovery of potential treatments. This kind of response has been possible because of unprecedented collaboration among the public and the private sectors, among scientists from all corners of the globe, and also because of the lessons the world learned in the aftermath of the West Africa Ebola outbreak of 2014. The emergence of the coronavirus reinforces once again the urgent need for continued investment in science and technology, for strengthening of healthcare infrastructure, as well as the need to improve public understanding and trust in science. That's why Johnson & Johnson supports programs like the AAAS Mass Media Fellows Program and our own Champions of Science initiative, because we believe we need more accurate reporting and engaging storytelling about science in order to continue to help people understand and support science and innovation. 2020 kicks off the decade of action for the United Nations Sustainable Development Goals. To make the progress that the world needs and to live healthier, happier lives, we need more citizens to support action on issues such as ending poverty and hunger and addressing climate change. We need people to understand that science offers a path for reaching these goals and how doing so can change the trajectory of health for everyone everywhere. Science must come to the rescue, and we need champions of science like you to make it happen. I hope you'll accept this challenge because with your commitment, we can engage people of all generations and backgrounds to help make the world a healthier place. Thank you.
Well, I wish she could have been with us, but it's wonderful to know that she's hard at work addressing critical issues of the application of science to very pressing real-world problems. And it's now time for our AAAS President's Address, and it's my great pleasure to be able to introduce our AAAS President, Steven Chu. Steve Chu is the William R. Kennan Jr. Professor of Physics and Professor of Molecular and Cellular Physiology at Stanford University. Dr. Chu is a very distinguished scientist who's held numerous significant positions and can claim a host of impressive accomplishments. He's published over 280 papers in atomic and polymer physics, biophysics, biology, bioimaging, batteries, and other energy technologies. He holds 15 patents and an additional 9 patent disclosures or filings since 2015. Notably, from 2009 to 2013, Dr. Chu was the 12th U.S. Secretary of Energy. As the first scientist to hold this cabinet position and the longest-serving energy secretary, Dr. Chu recruited outstanding scientists and engineers to the Department of Energy, and he began several important initiatives, including ARPA-E, the Advanced Research Projects Agency for Energy, the Energy Innovation Hubs, and was personally tasked by President Obama to assist in stopping the Deepwater Horizon oil spill. Prior to his appointment as Secretary of Energy, Dr. Chu was the director of the Lawrence Berkeley National Laboratory, where he was active in pursuit of alternative and renewable energy technologies. And a member of the Stanford faculty since 1987, Dr. Chu helped launch BioX, a multidisciplinary institute combining the physical and biological sciences with medicine and engineering. And previously, Dr. Chu was head of the Quantum Electronics Research Development Department at AT&T Bell Labs. Dr. Chu, of course, is the co-recipient of the 1997 Nobel Prize in Physics for his contributions to laser cooling and atom trapping, and he's received numerous other awards, and I will spare you the list tonight. He's a member of the National Academy of Sciences, the American Philosophical Society, and the American Academy of Arts and Sciences, and he's a foreign member of the Royal Society, the Royal Academy of Engineering, the Chinese Academy of Sciences, the Korean Academy of Sciences and Technology, and the National Academies of Sciences in Belarus. Dr. Chu completed his undergraduate degree in mathematics and physics at the University of Rochester and holds a PhD in physics from the University of California, Berkeley. He also holds 32 honorary degrees. I don't know if that's a record, but I was impressed. He became a member of AAAS back in 1995 and was elected as a fellow of AAAS in 2000. At the end of this meeting, Steve will assume the role of chair of the AAAS Board of Directors, and it is my great pleasure now to welcome you, Dr. Chu, to the stage.
All right, thank you very much, Peggy. I just want to tell the staffers of the AAAS it's 5 minutes to 6. So I'm going to talk about envisioning tomorrow and how we're advancing science and rising above several gathering storms. I am not going to talk about the exciting program that's there before you, and I hope you enjoy it. But I will quote the greatest American philosopher of the 20th century to lead this off, just in case you're wondering who that is. It's Yogi Berra, who on the right-hand side is seen in a philosophical conversation. And he said many, many wise things, but it's tough to make predictions, especially about the future, is very telling for this theme. What is rising above the gathering storm? I'm going to get a little bit more into this, but just to remind you, I was privileged to serve on this committee that wrote the report chaired by Norm Augustine, and also a revisiting of the gathering storm. But let me just move on quickly to the AAAS, and I want to give very personal visions of how I think we can improve things. So I am not speaking as the president of the AAAS. I am not speaking for the board. I am not speaking for the staff. It's just me. And I want to talk a little bit about science policy. I want to talk about science communication, dissemination of science to a larger audience, and reaching a growing membership. In fact, my ambitions are large. I would love to grow the membership by about tenfold. Why tenfold? Because physicists think in orders of magnitude. And so one of the things we are very proud of at the AAAS is that we coordinate the Science and Technology Policy Fellowship Program. And this is where we link scientists. Typically, they're young PhDs, graduate students who've just gotten their degrees and want to actually learn more about the federal government, but also use their expertise to give advice to the federal government. Most of the science fellows are supported by federal agencies, but there are 35 or so fellows, maybe 38, that are supported that go to Congress, because the congressional offices typically cannot afford to pay even a postdoctoral salary. And so the AAAS supports 2 of these congressional fellows. And I would love to see, and I'm working towards raising contributions to endow 6 fellows, because we pay for these fellows out of our operating budget. Okay, another thing that I would like to talk about is science communication. AAAS runs Sciline. You may not know about it, but I'm going to introduce you to it. Well, I'm not going to. And this is the thing in their website. Your story involves science. You need an expert. You need that expert now. And so I'm going to introduce you to Rick Weiss, the director.
Welcome everyone to this Sciline media briefing on the future of food, a particularly fun media briefing today featuring 3 experts looking at different aspects of what we might be eating in the years to come, and for some of us already. Before we get started, I just want to take 1 minute to introduce Sciline to those of you who may not be familiar with us. We are a philanthropically funded free service for reporters with one overarching mission, which is to help you get more research-based evidence into your news stories.
Okay, so that's Sciline, and it's one of the things I'm very proud of, the AAAS and the board are very proud of. Another thing we do is in the front section of Science Magazine, we publish weekly and daily things, and this is from a weekly thing where you can click on it, you get this picture, and this is, you can get news stories like Mission Impossible, how does the World Health Organization director fight to prevent a pandemic without offending China, and how it's going about. I want to pause a little bit briefly, take a little detour, and just remind you the coronavirus is worrisome, but the mother of all viruses was the Spanish influenza pandemic of 2018-2019. It was named the Spanish flu by the French, who had more political control. And it originated in France. And it infected about 27% of the entire world population, and the estimate it has killed 3 to 6% of the entire world population. The 2009 H1N1 virus, it's related to the Spanish flu, originated in Mexico and the United States, and it's estimated by the CDC to have killed between 150 and nearly 600,000 people. Okay? So what has happened? Well, the internet has happened. And so one has to keep this in mind. And then there's another fear that the experts are worried about. There's an Asian avian flu. It's called H5N1. There is a new outbreak in the last couple of days in China. It's transmitted among birds. Very weak transmission to people, but if a person gets it, they have a 60% chance of dying. So we have other problems. Let me go to some cheerful news about science communication. Science can be fun. And if you look at this cat, this is in some of the newsletters that we have, and this is a quote from this. Now, a new study shows that cats do, in fact, have facial expressions. Humans just aren't that good at interpreting them. And so 6,000 people were asked whether each cat expression is positive or negative. And it's pretty good. 59% said they correctly identified. But if you're a veterinarian or someone who works a lot with animals, you get more than 75% correct, with leading researchers to dub them cat whisperers. Now, this is just fun. And if we can bring this sort of fun of science to more of a general public, it would be great. Now, I want to go on and say that we have a membership. The membership is, this is a record of our membership over the past 3 years. Paid membership is about a little less than 100,000, and the upper curve is all members. Okay, the trouble with paid membership and the trouble with many scientists, young scientists, including graduate students and postdocs that I train today, say, well, I don't want to join AAAS and get Science Magazine. I get it free. And I hope to be a faculty member. I will still get it free. And so I think we need a new business model. This is actively being considered and pursued among the staff. And I just want to do a little advertisement of something I've been saying over the last several board meetings. And what about a Spotify membership model? So my apologies to AAAS. I hope you don't get sued by Spotify. And so maybe for $3 a month to support all the noble missions of the AAAS. I remind you that the American Civil Liberties Union has over 1 million members, more than about 10 times our membership, that pay at least $35 per year. What do you get? Well, you support the noble mission, you receive an electronic copy of the front-end section of Science, and I would like to see if we could develop, at very low cost, another front-end section that addresses the science can be fun, not only for professional scientists, people will have a real interest in science, but for a more lay audience, including K through 12 people. And so this communication is in my dream of what I want. Unfortunately, you know, as an officer of the AAAS, I'm only here for a very short time. This will take a long time, so I hope my successors and the able staff of the AAAS can do this. All right, more about envisioning the future. And so my vision of the future is really shaped by history. And so just to remind you of a very famous saying from a Spanish-American philosopher, those who do not remember the past are condemned to repeat it. Another version of this is a Gan Wilson cartoon, which says, you will make the same foolish mistakes you have made before, but not only once, but many, many times. All right. So let me turn the clock back 120 years or more. And it was the opening inaugural address of Sir William Crookes. And it was his address of the president of the British Association for the Advancement of Science. Now, I do not want the AAAS to stand up like the British Association for the Advancement of Science, because many of you, most of you have never even heard of this. Anyway, he began his address by saying, England and all civilized countries are in deadly peril. It is the chemist who must come to the rescue. Before we're in the actual grip of actual dirt, the chemist will step in and postpone the day of famine. With that address, he set off an international race to see if you can prevent starvation. What was the issue? The issue was natural fertilizer wasn't enough. We were actually getting fertilizer from South America, guano, that's a technical word for bird doo-doo, but they're going to run out of this nitrogen-based fertilizer. And so the prediction was in a couple of decades, Europe begins to starve. So that international race was won first and awarded a Nobel Prize to Fritz Haber in 1918. In 1931, Bosch, who worked with Haber to actually use high-pressure chemistry to actually make it work practically, got another Nobel Prize for the same work. And then many years later, Gerhard Erl got a Nobel Prize for his work on heterogeneous catalysis, where it says in the Nobel Prize statement that at last we're beginning to understand the Haber-Bosch process. So 2.5 Nobel Prizes. Why? Because it enabled the world to feed itself. All right. Science has done other things. Another really, truly great Nobel Prize in Peace was awarded to Norman Borlaug, who bred different strains of wheat to develop disease-resistant dwarf strain of wheat that had thick stalks and shorter so they can have the heavier kernels. And in this picture, you have the dwarf strains of wheat with the normal wheat. And from this work and the work of fertilizers, you look from 1960, where the population was 3 billion people, to 2005, where the population was 6.5 billion people. The blue and red curves are the production of grains, wheat, rice, corn, around the world, not in the United States, around the world. The black and dots are the amount of land put under agricultural cultivation. It remained the same. It actually went down. Okay, so science rose to the challenge. So the question is, will science meet the challenges that we face today? Climate change is the 8,000 pound gorilla in the room. But there are other challenges like internet, which spreads misinformation very rapidly as a threat to democracy. So let me talk a little bit about climate change. Are the glaciers melting? Is the sea level rising? The short answer is yes. But let's go back and look at history. I'm not going to look at climate models. And so if you go back and look in history, on the right-hand side is the present time, and as you go leftward, you're actually going back in time. And that red line is where we are today in temperature. Oh, sorry, the red line is 1.5 degrees to 2 degrees, I'm being generous, warmer than we are in temperature. And you ask in that last warm period, roughly 125,000 years ago, where was the sea level? It was 6 to 9 meters higher. So that's not a climate prediction, that's history. We know it's history because we know where the sea levels were because of the fossil records of critters that live between land and ocean all around the world. And so, now we thought this would take several thousand years. But with recent measurements in Antarctica and Greenland and other places, many people are now afraid most of this rise will occur in less than 250 years. So that's just the beginning. Water aquifers are being depleted in many parts of the world. We see increased droughts, heat waves, forest fires, water shortages, crop failures. And all those things could, in the near-term future, create climate refugees. So if you think of refugees going into Europe, 5 million or so, think of what would tens of millions to hundreds of millions of people would do. And these are where the water stress shortages are. When I was Secretary of Energy, I talked with the Indian ministers, and they were panic-struck that if the sea level rises in Bangladesh, many, many very poor people won't go inland and up in the mountains, they will go across the border. And one of the ministers asked me, what are we going to do? Do we shoot them at the border? Okay, so now, this is an IPCC set of scenarios of emissions on the vertical axis and time on the horizontal axis, many, many scenarios. So I'm going to do my own scenario. Here's my scenario. I just drew it because I think this is more likely because the emission scenarios to keep us to 1.5, maybe 2 degrees require negative world total emissions on all greenhouse gas by 2080. Let me say it again, it requires negative emissions by 2080. But this was actually made a year or two ago, and in order to keep that, we actually have to have more aggressive negative emissions. A very iconic picture that I talked about for many years, even before I was Secretary of Energy, is Earthrise. And it's from Apollo 8 that orbited the moon, and the last orbit, they turned the capsule earthward and took this picture. And the astronaut who took the picture said, we came all this way to explore the moon. The most important thing is we've discovered the Earth. Look at this picture. The moon is not a good place to live. No water, no air, no magnetic field, so you get lethal dose of radiation. Earth looks pretty good from this vantage point. Everywhere around, black. Okay, let's talk about it. One of the great discoveries over the last couple of decades was that there are many, many exoplanets, planets outside of our own solar system, estimated to be maybe 10 billion Earth-like planets within the reach of our own galaxy. So this is, on the left-hand side, a picture of a potential Earth-like planet, meaning that the temperature allows liquid water. And that's a picture of, we think, our Milky Way from afar. The photographer who took that picture had a very wide-angle lens. Anyway, this is the radius of the Milky Way. We are here over there. And you can do a little calculation. The time to travel 1/5 the radius of the galaxy, which gives you a reasonable probability of finding a good planet, will take 45 million years based on a very optimistic orbiting planet boosting that I made, where as the satellite goes around, let's say Mars, it goes in and gets a little boost up, and it goes around Jupiter, gets another boost up, and Venus, and all this other stuff. You don't get to these high velocities with chemical fuel. You use the planet. You slow down the planets a little bit, but you get the boost. Then you're traveling over 70,000 kilometers per second on your way, and it takes you 45 million years to get there. And when you get there, there's no way to slow yourself up and land safely. Okay? Forget about trashing this planet and moving on to a new world. We are here. All right, now, the UN goal to keep the temperature below 1.5 degrees requires we stay below 2,900 gigatons of carbon. This is where that danger line is. I just want to say that on the y-axis is total cumulative emissions. Why cumulative emissions? Because once you put the carbon dioxide up, half of it gets very rapidly absorbed by land and ocean, and the rest of it just circulates, land, ocean, and back up again. And the lifetime of the remaining half is estimated to be about 10,000 years. So don't think 2100, think 12,100, another decimal point. Most of the greenhouse gas emissions have occurred since 1950. Yogi Berra did not say that, but he could have. If you don't change direction, you might end up where you're heading. All right, I'm going to give you a little good news. Technology is happening. The cost of EV batteries has declined tenfold from 2010 to 2020. If you take where we are in batteries today, and that little dot is the 18650 style battery that Tesla uses for their S1. The hope is that we can get up to that green circle there. It's not a hope. I'm on the board of a battery company. I do battery research. And the battery company is now shipping samples with energy densities around double the energy density of current batteries, both in weight and in volume. All right, so EVs are projected to increase in sales from where we are today to perhaps by something like even very early, they're projected to be rising in sales. By 2040, it's been projected that perhaps 55% of light-duty vehicles would be EVs. Is there enough lithium? And the answer is, turns out there is. We're about to publish a paper that says you can get lithium from seawater in a very practical manner. If you do that, you've just increased the lithium reservoirs about 10,000-fold. Now, solar will continue to go down dramatically, at least another factor of 2. And if you go to Africa, and you will see pictures like this, when you wander around and you see people carrying things on their heads. You see people carrying water, walking kilometers by themselves. You see people pushing bicycles loaded with 100 kilograms of potatoes by themselves. Many of these people are so poor they can't even afford animals to do this. And imagine what would happen if you can bring very cheap solar energy to this population. However, it has to be really cheap and reliable, and with solar energy, you can have irrigation and water purification, where many countries, especially in East Africa, don't even have that, let alone transportation. But the introduction of very inexpensive but reliable electric 2- and 3-wheelers is possible, but for now, we need a new business model, and the little CapEx really drops down by another 5-fold. All right. But this is a possibility, and so maybe you can do this and bootstrap past petroleum-based transportation, just as cell phones did. Another very real possibility is that clean electricity can be less than 1.5 cents per kilowatt hour, and it's already 2 cents a kilowatt hour in the best solar sites in the Middle East. This is not just my dream. It is the firm prediction of oil companies. I'm an advisor to Royal Dutch Shell, and they are convinced by 2030, 2040 at the latest, renewable energy will be 1.5 cents a kilowatt hour. And the petroleum will peak around that time, petroleum used for transportation. And so this really opens up very exciting possibilities if the electricity is so cheap that you can use electrochemistry to make carbon-free hydrogen and other forms of clean energy. Let me move very quickly to agriculture. It turns out that more greenhouse gas emissions come from agriculture, land use, forestry, than from all of electricity generation around the world. And so I marked out in the orange and the blue methane. More than half the methane emissions in the world are due to agriculture and animal raising. Most of the N2O is due to fertilizer runoff. And so all this stuff is agriculture. And right now, because of the progress, we actually, more than half of the habitable land around the world is used today for agriculture and grazing. So this is already geoengineering on a grand scale. We've engineered everything we eat. Here's a quiz. I'm a professor. That's some corn. That's another picture of corn. That's another picture of corn. Can you pick out the native corn? It's unrecognizable. And so that has been bred. This is another picture. This is pictures of beef cattle, pigs, and broiler chickens. The full circumference of the circle denotes their natural lifetime. And the red part is when these animals are slaughtered from birth. They've been bred to grow very rapidly. American pigs are slaughtered in roughly 24 weeks from birth, and they weigh 280 pounds. So this livestock have been really optimized for very rapid growth, and many species, some of the birds, actually can't go to maturity because they're so disproportionately weighted they can't stand up. Now, another thing about geoengineering. If you think of all the mammal mass in the world, and on one side you put in wild animals, mice, rats, wild deer, buffalo, lions, and tigers, and bears, and the other side you put people and the animals we eat, it turns out that 96% of the mammal mass are us. 96% are us. We have truly engineered the world. We've engineered the animals. These are domestic turkeys, 3.5 months to slaughter. They are so breast heavy they can't mate, so they're mated through artificial insemination. All right? And we don't, so that's 3.5-month-old turkeys. They look very different than wild turkeys of unknown ages. I can only tell you how old this wild turkey is. 101 is 8 years old. Okay, think of the emissions. China and the United States lead the world in emissions. Both China has doubled the United States now, but the United States is more than the EU 28. If you look at just beef and dairy cattle, if they were a country, the greenhouse gases from beef and dairy cattle would be more greenhouse gas emissions than the entire EU 28. I should say EU 27 plus Great Britain. All right? This is a significant part of greenhouse gas emissions. And the good news is that there are developing very rapidly vegetable-based meat things that could hopefully gain traction and personal favor among the tastes. Younger people are gravitating towards that very rapidly. There's other good news that's happening. There's a startup company called Pivot Bio that's already started not only field testing, but it's now commercially been made available to some selected farmers, where corn and the microbes on the seeds of the corn have been such that when you plant the corn, the microbes interact with the corn and make the corn fertilizer, nitrogen-based fertilizer. And so the picture on the right is nitrogen-based fertilizer from corn, which greatly reduces the need for energy to make ammonia to make fertilizer, but also greatly reduces the N2O runoff, also a big problem with algae blooms as well as greenhouse gases. But if you really want a sustainable world, the world population cannot increase forever. This is not rocket science. And however, increased economic prosperity and global competitiveness in all countries is based on having more young people, more young workers support a smaller, older population. All right? This is known as a Ponzi scheme or pyramid scheme to cut through all the other stuff. Now, it was noted by our sponsor, there's a new Hans Rosling Center, and so I'm going to show you some data there. If you don't know this website called Gapminder, you should explore it. It's fantastic. And so using that, I plotted on the y-axis fertility rate, and on the x-axis income, average income of each country. You can pick any country you want, so I happen to pick India, Mexico, and the United States. And the dashed line is what you need for flat population, no growth, no shrinkage. And you see the United States is below that. You see that Mexico has gone, Germany, sorry, has gone below that. Mexico has gone below that. India, which is not a rich country, mean average income in US dollars is less than $8,000 a year. It is now at 2.2 to 2.3 fertility rate. So you don't even have to be rich to stop having babies. Why that is something of great debate. I can offer, women's education, lighting at night, something else to do at night, and like late night TV and other things. But that's just theory. The fact is that it's working. Even in Africa, it's beginning to work, except in East Africa, where the fertility rate is still 5, 6, and 7 per woman. But the hope is very, very quickly, as you bring them out of poverty, this goes down very rapidly because you don't want to pay for that many of your kids' college educations. Anyway, all right, we need a strategy how to increase prosperity in developing and developed countries with declining populations. And we need a different measure of wealth. Because as long as the measure of wealth is GDP, that means you're driven to increase production and consumption of stuff. 1 car per family is not good enough. 2 cars per family is good. 1 car per adult. One vehicle is the average in American adults. If you have the number of vehicles in America, including delivery trucks, taxis, and adults, it's 1-to-1 in US. All right? Do we want it to be 2-to-1? Do we want China to be 1-to-1, which is 1 in 20? And the answer is no. We have to redefine what we mean by wealth. And so think of what you treasure. It should be quality of health, including your health in old age. It should be education, including continued and renewal education, lowering of stress levels, connections, and family and friends. So we need to get onto these metrics before, otherwise we're going to be chasing, making, and consuming more stuff. On my remaining hour, I'm going to talk about a few things. I'm going to talk about immigrants and how they've added immensely to our scientific and technological excellence, and I'm going to report on a few other things. So let me talk about immigrants. The United States is a country of immigrants, and the brain gains we've had in science was stimulated by political events that were gifts to American science. And think of Germany and Italy in the 1930s and early 1940s. Think of China as the Communist Revolution was taking over. My parents came to the United States during World War II to go to graduate school at MIT. After the communists took over, they couldn't go back. They would be killed. My mother's father was a president of a major university. He had to exit for his life with nothing besides his life because he too would have been killed. That's my mother's father. My father's father was going to be killed, but they didn't get to the Shanghai area in time. He died of natural causes, so they did the only logical thing. They killed the oldest male child at the time in the family, who happened to be 21. So there are these gifts. The Cultural Revolution, Tiananmen Square, the Soviet Union allowed Jewish immigration. And also, in the last more than half century, graduate students and postdocs in foreign countries came to study in the United States and stayed because we're a free, open, and accepting society. And these students became US citizens, raised their families here, as my parents did. I don't speak Chinese. At the time, they said, you're going to grow up confused. We only want you to hear English. So they only spoke to us in English as we were growing up. All right. So let me remind you of immigrant contributions to American science. 143 immigrants in the United States have won Nobel Prizes. That's 34% of all laureates. That's if you count the first generation, but I'm second generation. If you count the second generation, it's harder to count. It's probably over 50%. All physics Nobel Prizes of laureates born in China came into the United States, got their PhDs, and got Nobel Prizes in the United States. There's something magical about the education system in the United States. If you look between, 2007 and 2019, the green are foreign laureates, Nobel laureates all around the world, except in the United States. The yellow are native-born US laureates, and the green, or whatever color that is, the light green, is foreign-born US laureates. This is staggering. My wife is Welsh, and she was particularly irritated in 2016 that 5 of the 9 Nobel laureates in the United States and 1 sort of Nobel Prize in economic science were British-born and British-educated with PhDs in Great Britain, but they started their careers in the US because of better opportunities. Okay, immigrants played an essential role in our national defense. If you look at the immigrants who worked in the Manhattan Project, it's a kind of an all-star list of many of them Nobel laureates, and the ones in red, Enrico Fermi, James Frank, Leo Szilard, Eugene Wigner, happened to be working in one University of Chicago metallurgical lab, all right? If you look at immigrant contributions in business, of the 44 of the top 100 so-called Fortune 500 companies, 45% were founded by immigrants or children. Includes Intel, Andy Grove, it includes Google, Sergey Brin, includes Amazon, Jeff Bezos, second generation Cuban, Tesla, Elon Musk, first generation South African, Yahoo, NVIDIA, and so on. So the contributions were enormous. And I now turn to a recent report. It was commissioned by the National Science Foundation. It was on fundamental research security. It's a JASON report that came out December of 2019. And in the early part of the report, it reminds us that as of 2017, foreign students represented 35% of graduate students throughout the sciences, health, and engineering fields. In the physical sciences, over 30% of the master's and over 40% of the PhD students are foreign. Also noting that China alone accounts for 34% of this total. So, while we're going to safeguard, I'll talk more about this, safeguard against attempts by China and other countries to gain early and inappropriate access to what US researchers are doing in fundamental research, the US should reaffirm the principles of the presidential directive. This is a little out of order, but I'm just saying that restricting international scientific collaborations with China and the non-approval of student visas of Chinese PhD students, anecdotal evidence of 2 universities I sampled, Stanford and Berkeley, suggests about 10% of the engineering students from China were not approved, and so they were frozen out of the class of 2019, 2020. They couldn't come to the United States, they're in China. And so this is having a polling effect on applications today. Now, a finding of the JASON report talked about so-called National Security Decision Directive 189, NSDD 189. It was stated in 1985, it was reaffirmed in 2001 and 2010, and it defines fundamental research. Fundamental research means basic and applied research in science and engineering, the results of which are ordinarily published and shared broadly within the scientific community as distinguished from proprietary research and from industrial development, design, production, and product utilization, the results of which are ordinarily restricted for proprietary or national security reasons. This directive goes on to say, it is a policy, and I put in, it was the Reagan administration, that to the maximum extent possible, the products of fundamental research remain unrestricted. It is also the policy of this administration that where the national security requires control, the mechanism for control of information generated during federally funded fundamental research in science, technology, and engineering at colleges, universities, and laboratories is classification. No restrictions may be placed upon the conduct or reporting of federally funded fundamental research. Okay. This directive is now being debated. We pull it back, just so you know. This is a directive that came out of the Reagan administration, reaffirmed by 2 other presidential administrations. So it's of concern. I point you to other documents to get different points of view than the Jason report, very much more hawkish points of view. There's an IP commission. I know about 1/3 of the people on this commission. They're good people, but they're raising concerns. There's a Senate report, Threats to U.S. Talent Enterprise, China's Talent Recruitment Plans. There's an FBI report that talks about the China Talents Program, where it says a large number of foreign students, researchers, scientists, and professionals in the United States, combined with current technological capabilities, allows foreign governments to contact and recruit individuals with the hopes of acquire advanced technology without research costs. It goes on to say, well, look what China is doing. And they pointed to one of the 5-year plans, 2011 to 2015. The report was issued just after that. And they listed topics. They're going to want to develop technology, new energy, nuclear, wind, solar power, energy conservation, environmental protection, energy reduction targets, biotechnology, drugs and medical devices, new materials, rare earths and high-end semiconductors, new information technologies, high-end manufacturing equipment, clean energy vehicles. Okay, so what are our science agencies doing under pressure from Congress? And so Paul Dabar, who's the Undersecretary of Science, was quoted in an article of Science Magazine as saying, we are not saying that universities can't take money from these countries. That's their decision. But if you're working for the DOE and taking taxpayer dollars, we don't want you to work for them at the same time. Employees at the DOE's 17 national laboratories would be given the choice of either severing their foreign ties or leaving their job, he says. Academic researchers who maintain their foreign collaborations would no longer be able to compete with DOE grants. Many of my friends are at SLAC and Berkeley Labs say if they're doing ultra-fast basic research, they simply cannot travel to China with any DOE label, period, just to go to a conference. The NIH has said that it requires that PIs must declare all significant foreign support, which is totally fair. Direct financial support of graduate students, completely justified. But in a frequently asked questions section, they state that significant support should include materials or reagents not available commercially. That policy actually conflicts with the policy of Science magazine, which says after publication in the fine print, all reasonable requests for data, code, or materials must be fulfilled. If a researcher says, can I have your plasmid? You have to give it to them. And now the NIH is now requiring that if a PI wants to collaborate with any foreign scientist, whether it be China or Germany, or will actually take data with their collaborator friend in this foreign country, for example, a cryo-EM setup in Germany, you need prior approval. And they're actually rejecting approvals, and they have to be appealed, including actually collaborations from Germany. Okay. Now, China's 12 5-year plan is amazingly remarkable resemblance to the goals I was pursuing while I was Secretary of Energy. And so I'm going to take you back to a talk I gave at the National Press Club in Washington, D.C. at the end of November 2010. And the title of the talk was, Is the Energy Race Our New Sputnik Moment? And so it begins by saying, look, in October 1957, the Soviet Union placed a 184-pound satellite into orbit. And it showed a picture of the New York Times headline. And I talked about President Eisenhower's speech that came about a month later. And he did not respond by calling for increased military spending. Instead, he said the following. According to my scientific friends, one of our greatest and most glaring deficiencies is the failure of us in this country to give high priority enough to scientific education and to the place of science in our national life. One great failure danger that no amount of money or resources currently devoted can fully meet is education. Education requires time, incentive, and skilled teachers. They believe the second critical need is of giving higher priority, both public and private, to basic research. Amazing response from one of the 2 5-star generals in the history of the United States. And I was 9 years old at the time, and I was part of many, many post-Sputnik science programs in high school, college, and beyond. And that trained a huge new core of American scientists. All right, this is my talk in 2010. Innovation adds to the wealth of society. Innovation and technology are at the heart of innovation, and leadership in innovation cannot be taken for granted. I gave some examples. Model T Ford, first transistor, integrated circuits, the first airplane, satellite communication, GPS, the internet and internet search engines like Google. But let me remind you that Henry Ford did not invent the internal combustion engine. He did not invent the assembly line. He improved upon those things and made it low-cost manufacturing. Sound a little familiar? Okay. I went on to say, for over a century, America has led the world in innovation. Today, technology is at risk. I gave some examples. In 2009, 51% of US patents were awarded to non-US companies. China has gone from 15th place to 5th place. This is according to Rising Above the Gathering Storm. The World Economic Forum ranks the US 48th in quality of mathematics and science education. China's Tsinghua and Peking universities are the 2 largest suppliers of students who receive PhDs in the United States. Then I quoted the then premier of China, Wen Jiabao, and said, we should use scientific and technological innovation as an important pillar and to develop new industries of strategic importance. Science and technology is a powerful engine of economic growth. We will accelerate the development of low-carbon economy and the green economy so as to gain an advantageous position in the international industrial competition. I went on to say we face a choice today. Will we maintain America's innovation leadership, or will we fall behind? And that we had to seize this innovation opportunity, and we can't afford not to. I talked about new initiatives like RPE and energy innovation hubs, but I also said that there's a difference between the Cold War and the Sputnik challenge and all these other things. Because while you're competing for leadership and innovation, we have much to gain with cooperating with China, India, and other countries. And that in the next 2 decades, in 2010, I said China will build new buildings to house 350 American people, more than 1 US population, and they're building another for another 300 million people, another US population. And in 80% of India, infrastructure does not exist today. And these countries will provide us with markets and laboratories for innovation. Let me fast forward to today. Here's a postscript. What China wants in their 5-year plan, as warned by the FBI, sounds chillingly like what we wanted when I was Secretary of Energy. And then 2 weeks after I gave the speech, Obama actually talked about it, the Sputnik moment, in his State of the Union address. I went back and looked at data of comparing Chinese EU28 US support in R&D, and I looked up the last 3 points of data so I can project them, because you have to look at those separately, and we see that China has now pulled ahead of the United States. So what is the proper response? The US should respond by increasing investments in science, technology, and STEM education, not by erecting walls to international collaborations. I'm going to return to Eisenhower's speech because there's something he said that was amazing. Although tonight's purpose, I stress the influence of science on defense, the peaceful contributions of science to healing, to enriching life, to freeing the spirit. These are the most important products of the conquest of nature's secrets. We shall never cease to hope and work for the coming of the day when the scientist can give his and her full attention, not to human destruction, but to human happiness and fulfillment. That was pretty good stuff. I want to also quote from a current postdoc, Cornell, a high energy physicist, and she immigrated to the United States in 2009, got her PhD at the University of Chicago in physics, and now is a Cornell postdoc, and she wrote a column, 2019. And she asked the question, what is the role of science in affairs of state? And she goes on to say that her mother, who wasn't thrilled with her going into science in the first place, but it speaks of her conflicted decision to be part of the March on Science in April 17. There are people within the AAAS staff and outside who are also conflicted. Is this part of the AAAS? Are we becoming political demonstrators? And so she struggled with this. And she quoted her mother, "Focus on your profession," my mother warned. "Don't talk about politics. Don't participate in politics. Don't ever join street demonstrations." My mother told me that too. I never have joined a street demonstration. So anyway, but the point here is that creativity and science flourish best in an open environment. Why? Because democracy cherishes free speech, the open flow of information, and the ability to openly question political leaders. And in science, observation and experiments remain the ultimate arbitrator of truth. And if it weren't for a Google search engine, my effectiveness as a researcher would be greatly diminished. China has no access to Google search. And so, I actually was giving a speech in China where I said, this is not good. Open up Google search. Okay, so how could we respond to Chinese theft? And so let me give you a little bit of history that many of you may not know about. So on September 2015, President Obama met with Xi Jinping. And there was increasing evidence that there was more industrial spying going on. Finally, the president says, look, we've got to stop this. And when I was Secretary of Energy, my 4.5 years, 4 to 3 years, I said, this is a new Cold War. We've got to damp it down. And so at a news conference in September 2015, they announced that both countries agreed not to use the tools of national cyber tools, which are considerable, much more powerful than private companies, to help companies engage in economic espionage. And the deal specifically didn't cover, it covers the theft of trade secrets, but not national security information. That was considered spy versus spy stuff, that's okay. But companies, no, don't use the tools. So what happened? President Trump canceled the agreement when he became president, as he did the Paris Accord, as he did the Intermediate Continental Ballistic Missile Treaty, as he did the agreement with Iran, and miraculously, industrial espionage increased from China. All right, what can we do about it? First, let's acknowledge that there are real issues. And it's my view, and I've been talking about this publicly and also privately in the last several months, that efforts to obtain information before researchers are ready to publish or post is scientifically unethical, that faculty members who receive significant support from institutions should declare it, and they have to disclose connections. And any contract that asks a faculty member in the US to not disclose the contract to their home institution should be simply banned, as it is in the NIH. Let's see, what did I say? And there could be no conflict of commitment with one's home institutions. And so I feel very strongly it's the responsibility of the professors to teach scientific ethics to their students, from demanding full reproducibility of scientific results to publishing everything in the methods section that enables the competition to repeat their experiment, which is not always done. In Stanford, in the medical school, we give a required class on scientific ethics. All right, let me turn to the last thing, the need to rebuild trust across America. And retreating into our own little bubbles that we can so effectively do in the internet is not building trust, or building walls between countries don't build trust. So I'm going to take you back to an episode of The West Wing. How many people have seen The West Wing? Okay, good. So this is about Robert Frost, who wrote this poem called Mending Fences, and do good fences make good neighbors?
Here he quotes Robert Frost, good fences make good neighbors. Did he talk about that?
Yeah.
What did he say?
Basically that if you stay within your personal space, you'll end up getting along fine with everyone.
You had to study modern poetry.
Yes.
Is that what Frost meant?
No, he meant that boundaries are what alienate us from each other.
Why did he say good fences make good neighbors?
He was being ironic, but I still don't see.
This was missed by some politicians, that Frost was being ironic, that good fences don't make good neighbors. When you erect barriers, you don't interact with them, and you increase suspicion. Let me tell you another story, a personal story. I was in this committee, Rising Above the Gathering Storm. We were trying to sell it to the President of the United States, George Bush. I had a good friend, Condi Rice. She agreed to see me. I brought along Chuck Vest, the former president of MIT, and Ralph Cicerone. So we met with her an hour, explained to her how important the program was. I met with another good friend who was then Secretary of Energy, Sam Bodman. I spent an hour with him talking about how important it was. But we couldn't make any headway with the big cheese. So I called up someone on the committee named Peter O'Donnell. And I said, Peter, because at the end of this work, he says, Steve, I like you. If you ever need a favor, just call me up. All right, late November, I called Peter. Peter, this is Steve. You're a good friend of the president. We got to get in front of the president of the United States. So he says, well, Steve, I know about the education part. What about the rest? I said, Peter, it's all good. A little pause. Okay, Steve, I trust you. But before I bring it to the president, I got it before Don Evans, who was then Secretary of Commerce, a very close personal friend of the president. And because he's just going to turn around the president and say, well, boss, what do you think? And I said, Peter, that's exactly what Secretary Bodman told me. He says, Steve, I know that. So months go by, it becomes part of this State of the Union address of President Bush. It becomes part of his budget to do the things we were suggesting in Rising Above the Gathering Storm. A month later, I'm in the Department of Energy. The Deputy Secretary says, Steve, we owe you a great favor. We were pulling the same direction. The then Secretary of Energy and the department and I was. And he said, well, what do I do? He said, you don't know what happened? No. The president has a private dinner with Don Evans and the First Lady. He gets called away for the next 45 minutes. Don Evans bent the First Lady's ear, how great the report was. Who knows how long it took the First Lady to bend the president's ear, how great the report is, and it makes the State of the Union in the budget. It was all personal trust and contact, okay? And now I'm gonna end by saying, but that's just a little story. This is and I apologize for the movie, it's a bit long, and I'm gonna end on this, but it's Mr. Rogers on building trust. Let me set the stage. He's going before a congressional committee, the US Senate Commerce Committee, to request to support national public television. The chair of the committee was not disposed to doing it. He's going to put up with the hearing, and then he's going to say no. And so, and Mr. Rogers wasn't appreciated the way he is today. He was also partially under attack for being a little too lenient with young people. You know, totally, you know, give them love and acceptance was a little, you know, you need a little bit of tough love as well. So, that's the stage.
It's ever happened to public television, and his Peabody Award is testament to that fact. We in public television are proud of Fred Rogers, and I'm proud to present Mr. Rogers to you now.
All right, Rogers, you got the floor.
Senator Pastore, this is a philosophical statement and would take about 10 minutes to read, so I'll not do that.
One of the first things that a child learns in a healthy family is trust. And I trust what you have said, that you will read this. It's very important to me. I care deeply about children. My first children...
Will it make you happy if you read it?
I'd just like to talk about it, if it's all right. Okay. My first children's program was on WQED 15 years ago, and its budget was $30. Now, with the help of the Sears Roebuck Foundation and National Educational Television, as well as all of the affiliated stations, each station pays to show our program. It's a unique kind of funding in educational television. With this help, now our program has a budget of $6,000. It may sound like quite a difference, but $6,000 pays for less than 2 minutes of cartoons, 2 minutes of animated, what I sometimes say, bombardment. I'm very much concerned, as I know you are, about what's being delivered to our children in this country.
He's talking
And
about
I've
violence
worked in
in
the field
cartoons.
of child development for 6 years now, trying to understand the inner needs of children. We deal with such things as the inner drama of childhood. We don't have to bop somebody over the head to make him to make drama on the screen. We deal with such things as getting a haircut, or the feelings about brothers and sisters, and the kind of anger that arises in simple family situations. And we speak to it constructively.
How long a program is it?
It's a half hour every day. Most channels schedule it in the noontime as well as in the evening. WETA here has scheduled it in the late afternoon.
Could we get a copy of this so that we can see it? Maybe not today, but I'd like to see the program.
I'd like very much for you
I'd like to see the program itself, or any one of them, you see.
We made 100 programs for EEN, the Eastern Educational Network, and then when the money ran out, people in Boston and Pittsburgh and Chicago all came to the fore and said, we've got to have more of this neighborhood expression of care. And this is what I give. I give an expression of care every day to each child to help him realize that he is unique. I end the program by saying, you've made this day a special day by just your being you. There's no person in the whole world like you, and I like you just the way you are. And I feel that if we in public television can only make it clear that feelings are mentionable and manageable, we will have done a great service for mental health. I think that it's much more dramatic that two men could be working out their feelings of anger. Much more dramatic than showing something of gunfire. I'm constantly concerned about what our children are seeing. And for 15 years I have tried in this country and Canada to present what I feel is a meaningful expression of care.
Do you narrate it?
I'm the host, yes. And I do all the puppets, and I write all the music, and I write all the scripts.
Well, I'm supposed to be a pretty tough guy, and this is the first time I've had goosebumps for the last 2 days.
Well, I'm grateful, not only for your goosebumps, but for your interest in our kind of communication. Could I tell you the words of one of the songs which I feel is very important?
Yes.
This has to do with that good feeling of control, which I feel that children need to know is there. And it starts out, what do you do with the mad that you feel? And that first line came straight from a child. I work with children, doing puppets in very personal communication with small groups. What do you do with the mad that you feel? When you feel so mad you could bite. when the whole wide world seems oh so wrong, and nothing you do seems very right? What do? Do you punch a bag? Do you pound some clay or some dough? Do you round up friends for a game of tag or see how fast you go? It's great to be able to stop when you've planned a thing that's wrong and be able to do something else instead and think this song. I can stop when I want to, can stop when I wish, can stop, stop, stop anytime. And what a good feeling to feel like this and know that the feeling is really mine. Know that there's something deep inside that helps us become what we can. For a girl can be someday a lady, and a boy can be someday a man.
I think it's wonderful. I think it's wonderful. Looks like you just earned the $20 million.
Okay, let me just end by saying, when I was Secretary of Energy, I had many quiet conversations with members of Congress, both sides. Nothing ever became public of those conversations, because if it ever does, you break the trust. I think the AAAS can try to help mend the fences. Not mend the fences and erect walls, but mend the bridges between the Republicans and the Democrats. That you meet with small groups from both parties at the same time, 1 or 2, 3. And we need to do this in order to rebuild the trust, because there are good people on both sides of the aisle. And so I will end by just saying that that is one of the visions, and in my remaining year as AAAS, I pledge to do with the new CEO, Sudip. And so this is very important for me also. Thank you for listening. I'm not sure what comes next. Are you all excused, or is there Q&A? You're all excused. You're all invited to the reception, I've been told. All right, thank you. Hall 4B. Thank you.